This is the 2020 probability question 6 in the Leaving Cert. That was in November for the first time ever. 30% of cars ran on diesel. So we want to always get the total at the beginning of these, what look like a tree diagram. 30% diesel, so 0.3 we'll call diesel, 0.6 petrol, and 0.1 we'll call H for hybrid electric. And what are we told? 70% of these diesel were Volkswagen. Well, really high percentage, 70% of them. So 30% of them weren't. We don't think we need that in this question. I've read it through. 25% of these were, of these 60% that were petrol were Volkswagen. And if you look down, they're asking the probability of a Volkswagen car. And of the hybrid, of the 10% of the total, 9% of them were Volkswagen. 0.09. So this will give us how many Volkswagens were there in the sample. 7 trees, or 21 with 2 decimals. A quarter of 60% is 15%. And if we multiply 0.09 by 0.1, it will move the decimal one place to the right. So we have 36 with a 9 at the end. So that's the first part. Keep it nice and simple, nice multiply probability. Nothing too difficult. The Road Safety Authority has data on driving test pass rates at all its test centres. In a particular driving test centre, the probability that a person taking the test for the first time will pass is 1/4. All the results are independent. Okay, independent events. We can use Bernoulli trials. In this test centre on a particular day, Joe, along with 5 others, take the test. All 6 are taking the test for the first time. Well, some amount of information in this question, but really it's just a simple Bernoulli trial. Find the probability Joe passes and exactly 2 others. So we're looking at, leave Joe out of it. We know Joe, we're going to multiply by 1/4 the probability of Joe passing. So there's 5 others. Exactly 2 of them have to pass. 5 choose 2 is 5 by 4 over 2 by 1, which is 10. Multiplied by the probability of these 2 guys, the probability of success, the probability of them passing is 1/4, and there's 2 of them. So we know that 3 guys didn't pass, so the 2 and the 3 give you the 5 in here. The 2 powers add up to that number, and the probability of them not passing is 3/4 to the power of 3. And if we multiply by Joe's 1/4, this is going to give us 0.0659. So if you have practiced Bernoulli trials and you see it coming up, it's literally one line of information. Type it into your calculator. You're delighted with yourself, you're gaining confidence, you're moving on, and you're more likely to do better in the next question. So the more of these key components that you keep learning off, the better. Okay, last part of this question. The overall pass rate for drivers at another centre is 1/2, whether first attempt or not. So success and failure are the same here. The probability of success we'll call 1/2, and the probability of failure is 1/2. We will be using Bernoulli trials here. The probability that 2 people are less. So 2 people are less. Well, you may get confused that it's just the probability of 2. But the probability of 2 or less is the probability of 2, 1, or 0. So let's have a look at the probability of 2 first. I think we have to add all these 3 together. Now, looking at the size of the box, you kind of maybe jump to the assumption that we just look at the probability of 2. So let's look at the probability of 2. We will look at 1 and 0 and bring them in. And we might look at 2 possible answers here. So the probability of 2 is going to be, we don't know how many the sample is, but we're having 2 successes. So when you know your Bernoulli rules, it's the probability of success. In this case, it's the same as success and failure, but it doesn't matter. You lay it out the same. The probability of success, this is the amount of successes, this 2. And the total, if it was 10, would have an 8 here in this position. But we have n minus 2. We're just going to rub that out so you can see it. We have n minus 2. 10 minus 2 would give 8. 5 minus 2 would give 3. So the 2 powers add up to n. n minus 2 plus 2 is just n. And the probability of failure is 1/2. We have to the power of n minus 2. Now, n, choose 2 is n, whatever number that is, by the 1 before it, divided by 2 by 1. We'd have to multiply this guy by 1 over 2 squared. I might just leave the indice as a 2 squared for now, and multiplied by 1 over 2 to the power of n minus 2. And if we just multiply the top out, we're going to get n squared minus n divided by 2. The 2 and the minus 2 will cancel, so we're left with 2 to the power of 1 plus n here, so 2 to the power of n plus 1. So we have the denominator, so maybe on initial inspection it looks like we have our answer here, and a is 1 and b is minus 1. But if we look at the probability of 1 and the probability of 0 as well, it is unusually, not brilliantly phrased, so I'm not 100% sure what they meant. We'll see when they bring the marking schemes out. The probability of 1 success is 1 success from n by the probability of success to the power of 1 by the probability of failure to the power of n minus 1 in this case. So now we're going to have n choose 1 as n, and on the bottom we're going to have 2 to the power of 1 from in here, and 2 to the power of n minus 1. So that's, if we add our indices, it's n over 2 to the power of n, it looks like. N over 2 to the power of n. So this is where the space here may have thrown you about what was being asked. So the probability of 0 is n choose 0, and n choose 0 is equal to 1 by the probability of failure to the power of 0, by the success to the power of 0 by failure to the power of n. So in this case we're just going to get 2 for they're about 1, so we're just going to get 1 over 2 to the power of n, which is the same as 1 over 2 to the power of n, because the 1 to the power of n is just equal to 1. So if we have these two, we can add them together. That's going to give n plus 1 over 2 to the power of n. Now to get a 2 to the power of n plus 1 on the bottom, which we see over here, we can bring in to get a 2 to the power of n plus 1, if I just multiply that by 2 there, we've got 2 to the power of n plus 1. So if I do the same to the top, I'm not changing the value of this. So on top I'm going to get 2n plus 2, and on the bottom I'm going to get 2 to the power of n plus 1. And now I can bring this guy and this guy together, which I think is what they were looking for in this case. N squared minus n plus 2n is plus n, and plus 2 over 2 to the power of n plus 1. So just double check that, yeah, that's a minus and a plus, so that gives a to be 1, this 1 here, b to be 1, this 1 in here, and c to be 2. So tricky enough question with not a huge amount of space given. 2020, the leaving cert you never took.